Hello friends, in today's class of electromagnetic field theory, we are going to solve this problem. Here, the two vectors A and B are given in their component forms, and we have to find out the angle between A and B and the component of A along B. Now, let's start with the problem A. Here we have to find out the angle between A vector and B vector. We can find this by using simply dot product or cross product. Now, we use here the dot product. A dot B equal to mod A mod B cos theta. This theta is the angle between A vector and B vector. We know this relation. Now suppose this is the B vector and this is the A vector, then this is the angle between these two vectors and we have to find this theta. Now cos theta equal to A vector dot B vector by mod A mod B. Now theta equal to cos inverse A vector dot B vector by mod A mod B. Now to calculate this theta, we have to calculate mod A mod B and A dot B. Now calculate mod A equal to, first of all, we will write this A vector and B vector in their general forms. We can write A vector equal to AX IX unit vector plus AY IY unit vector plus AZ IZ unit vector. That means AX is equal to 4, AY is equal to 3 and AZ is equal to 0 because we are not getting here any component of IZ, that means AZ is 0 here. We can write B vector equal to BX IX in general form plus BY IY unit vector plus BZ IZ unit vector. That means BX equal to 3, BY equal to minus 2 and BZ equal to 4. Now mod A vector equal to AX square plus AY square plus AZ square equal to root over. X is 4, 4 square plus 3 square, this is 0, let it be. 16 plus 9 equal to root over 25 equal to 5. Now mod A equal to 5. Now we will calculate mod B equal to root over BX square plus BY square plus BZ square equal to root over BX is 3, 3 square plus BY is minus 2 square plus BZ is 4 plus 4 square equal to root over 9 plus 4 plus 16 equal to root over 16 plus 4 20, 20 plus 9 29. Then mod B vector equal to root over 29. Now we have to calculate the dot product between A and B vectors. And A dot B, we can write it in another form where the components of A vector and B vectors are given. Then we can write A dot B equal to AX BX plus AY BY plus AZ BZ equal to AX is 4, BX is 3 plus AY is 3, BY is minus 2 plus AZ is 0 and BZ is 4. 12 minus 6 plus 0 equal to 6. Now A dot B is equal to 6. A dot B equal to 6. Now theta equal to cos inverse A dot B means 6 by mod A means 5 and mod B means root 29, and theta equal to cos inverse 6 by 5 root 29. By calculating this, we can calculate cos inverse of this and we will get the angle theta, the angle between A vector and B vector. Now come to the problem B. Now we will solve the problem B. In this problem, it is said to find out the component of A vector along B vector. When it is said component of A vector, that means we have to find out the vector component of A vector. Okay, if it is said projection of A vector along B vector, then we have to find the scalar component of A vector. And when it is said component of A vector, then we simply find the vector component. And to find the vector component of this vector, we have to calculate first the scalar component. And the scalar component of this one, how we can calculate? We can calculate it by taking the projection of this A vector along B vector and take a unit vector here, IB. Okay. Then AB, which is a scalar, okay, scalar component of this A vector equal to A vector dot IB unit vector. The dot product of two vectors gives a scalar quantity. This is the scalar component of this A vector along B vector. Now we have to calculate this IB unit vector. How we can calculate it? IB unit vector equal to B vector by mod B vector. B vector is given here, 3ix unit vector minus 2iy unit vector plus 4iz unit vector divided by mod B, we already calculated, root 29. Then IB unit vector equal to 1 by root 29, 3ix minus 2iy plus 4iz unit vector. Now we will write here IB unit vector equal to 1 by root over 29, 3ix minus 2iy plus 4iz unit vector. Now we will calculate this scalar component AB equal to, simply we will write AX CX plus AY CY plus AZ CZ. Here CX, CY and CZ are the coefficient of IX, IY and IZ of this unit vector. Cx equal to 3 by root 29, Cy equal to minus 2 by root 29 and Cz equal to 4 by root 29. Now calculate. Ax is 4 into 3 by root 29 plus Ay is 3, Cy is minus 2 by root 29 plus Az is 0 and Cz is 4 by root 29 equal to 12 by root 29 minus 6 by root 29 plus 0 equal to 6 by root 29. This is the scalar component of A vector along B vector, that means AB. Here we will write AB equal to 6 by root 29. Okay. Now we will find the vector component of A along B. How we can find it? A, B vector by multiplying this scalar quantity with this unit vector. Then we will get a vector AB, IB unit vector. Just multiply this scalar with unit vector IB. What we will get? AB is 6 by root 29 and IB is 1 by root 29, 3ix unit vector minus 2iy unit vector plus 4iz unit vector. Now 6 by 29, 3ix unit vector minus 2iy unit vector plus 4iz unit vector. This is the vector component of A vector along B vector. Okay friends, thank you.